is CORDIScovery. Hello and welcome to this episode of CORDIScovery with me, Abigail Acton. The EU is intending to have all sectors of the economy at net zero greenhouse gas production by 2050. But heavy industry and transport can be challenging to electrify directly, so renewable and low-carbon hydrogen and its derivatives are key tools in the box. From less than 2% of our consumption in 2022, by 2050, it's estimated that hydrogen will account for around 10% of the EU's energy needs. To get there, we need to create a stronger demand for the fuel, boost transport and storage networks, and secure the renewable, affordable electricity needed to generate low-cost hydrogen. Our three projects today, all of which received support from the EU's research and innovation funding schemes, have some solutions. Magali Senaux is keen to see the day when buses passing you by in the streets no longer belch fumes at you, instead leaving nothing but a dribble of water. She's helping to ensure as many European fleets of buses as possible are powered by hydrogen and is working to bring down barriers to their use. Welcome.
Hi, Abigail. Thank you very much for the invitation.
Well, it's lovely to have you today. Melanie Leoneth is passionately interested in hydrogen-powered flight, which she brings closer at H2Fly, the company behind a test flight believed to be the first forward flight of a vertical takeoff and landing aircraft powered by liquid hydrogen. Hello, Melanie.
Hi, Abigail. Thanks for having me.
You're welcome. Benedikt Hasibar is a project coordinator at Green Gas Technologies at RAG Austria AG, Austria's largest energy storage company. Benedikt is working on the development of effective and efficient hydrogen storage. Hi, Benedikt.
Hi, thanks for having me.
Magali, I'm going to turn to you first. Hydrogen fuel cell buses offer cleaner public transport, and the Drive 2 project is helping to encourage the commissioning of fleets around Europe. So how did the Drive 2 project help to make hydrogen-fueled buses a more feasible option for people in charge of commissioning new fleets?
Yes, good question. So Drive 2, in tandem with its project sister project, Drive, set out to achieve something quite ambitious, which was to support and move hydrogen buses from just demonstration vehicles to an everyday reality. Earlier funded initiatives had tested hydrogen buses, but Drive and Drive 2, funded by the Clean Hydrogen Partnership, were the first to deploy them at such a scale, with fleets varying from 5 to more than 50 buses. And the goal was very clear, to accelerate the commercialization and large-scale deployment of hydrogen buses and integrate them in the commercial fleets. What I found most interesting with the projects is how they helped shift perceptions. So hydrogen buses are no longer just a futuristic concept. They are out there, they're in the streets of various European cities, and they're carrying passengers on a daily basis.
Excellent news. Can you tell us a little bit more about the cities that are involved and what they did?
Yes, of course. So cities like Barcelona or Cologne are a great example of the project's impact, among others, of course. Cologne, for instance, was involved in several European funded projects and now have one of the largest hydrogen bus fleets in Europe. Barcelona joined Drive 2 after being part of the initiative's observer group. And when they joined the project, they committed to 10 buses, which then opened the door to further interest. And they now ordered an additional 38 hydrogen buses.
Fantastic. And in Cologne, you mentioned one of the largest fleets. How many does Cologne have?
Within Drive 2, they're at 50 buses. And now they have more than 100 fuel cell buses.
Oh, that's fantastic. And what were some of the barriers? What did the project come across that was causing this not to happen? And how did you resolve them?
Yes. So, of course, naturally, when you deploy a technology whose ecosystem is still maturing, you will encounter challenges. And those can be technical issues with both the side of the buses, but also, of course, the refueling infrastructure that you have to put in place to refuel those buses. There are also questions around prices, the availability of green hydrogen. But of course, all these challenges really led to stakeholders gaining learnings and gaining knowledge on how to treat them, to communicate to one another thanks to this initiative. And sharing this accumulated knowledge and ensuring that areas of improvement are addressed is really crucial for continued progress.
Could you give us an example? For example, if we think about fueling challenges, was there anywhere that came up with a new way of dealing with that?
I think there was a lot of discussions around having systems that are redundant. That means to ensure that in case one piece of your equipment fails, that there's a second part that can take over and continue delivering the hydrogen. That has been, for instance, one of the key learning, which is now being implemented with new projects to ensure that that issue is dealt with.
Yeah, sure. You don't want suddenly something to go wrong and everyone's left high and dry. Yeah.
Exactly.
I think I noticed that not far away from me in the UK, that did you mention something about Brighton and Hove putting in place some? What happened there? What did they do? Can you remember?
Yes. So Brighton and Hove have implemented one of the first liquid hydrogen refueling stations. So the hydrogen is stored on site in liquid form and then transformed into gaseous to get into the buses. And that was quite a big project. And that specific site in Brighton and Hove buses are also part of those largest fleets to date, as within the projects, they have around more than 50 buses, hydrogen buses, that are being in operation in the area.
Well, fantastic. A little inside knowledge. I live in Brighton, so I shall keep an eye out for one of those buses. Excellent. Thank you very much. What do you feel most satisfied about when you look back at the project? What do you feel is a key takeaway?
I think what's been amazing of being part of such a large-scale project that's taking such a diversity of areas is actually seeing the buses in operation. When I joined the project at first, there were very few buses that were actually operating. Some were still finalizing their bus orders or waiting for the buses to be delivered. And as the project progressed, it was always an immense pleasure when you visit a city and to see the buses, sometimes as soon as you stepped out of the train station, for instance, in Groningen in the Netherlands. And I personally don't come from a technical background, so I learned a lot about hydrogen and its potential for public transport through these very projects. In my opinion, decarbonizing public transport, of course, is essential to building sustainable societies, and hydrogen buses are an option to do so because they replace diesel buses. And the projects such as Drive and Drive 2 really enabled to give cities hands-on experience with this technology to demonstrate what hydrogen buses can offer and really help the decarbonization journeys of cities for those that decide to go with hydrogen buses as one of the technologies to have in their fleets.
Fantastic. Super. Yeah, very well explained. Thank you. I'm sure that the general public is actually quite keen as well to know that they're on a hydrogen-powered bus. That must be quite a thrill as well, because it's still relatively new, isn't it? Super. Thank you. If you were to project yourself, say, 5 years in the future, do you think that hydrogen buses would be pretty ubiquitous? Do you think we'd be seeing a lot of them around? Is this going to grow and grow, do you think?
I think what's very interesting is that the decarbonization strategy of public transport is very unique from one city to another and needs to be adapted to local requirements and conditions. And in the projects, we've seen that hydrogen buses can really respond in some of the areas where actual battery electric buses are not yet meeting the needs. So it is possible that in certain areas, you will see a growth, of course, of hydrogen buses because that's currently the only solution adapted to the specific situation. So I think there will be a growth, maybe even coaches going from longer distances. That's also very interesting. but we're going to see a very big mix. And of course, hydrogen buses will be in that mix.
There we go. Not in small part, thanks to Jive 2 project and your work. Well done, you. Excellent. I'm going to turn to Melanie now. Melanie, the Heaven project set out to design, develop and integrate a powertrain based on a high-power fuel cell and cryogenic technology into an existing 2 to 4-seater aircraft for flight testing. So what is needed, Melanie, to go from test flights to uptake by the commercial aviation sector? It's a huge jump.
Yes, definitely it is. So I think what is important to know that the technology around fuel cell and liquid hydrogen is a technology that enables medium-haul zero-emission flight operations. And with that project, we wanted to show that zero-emission flight isn't just something theoretical, just a concept on paper, but something that really works in real flight conditions. And I think what made this project super exciting is that no one had ever done this before. That's really a world's first. So what I can say to give you a little bit of background is that at H2Fly, we already proved hydrogen electric flight was possible back in 2016 already with the very first hydrogen powered flight. And also, after that, we ran several successful test campaigns between 2020, 2022. But what you need to know is that all of those flights used gaseous hydrogen. And to achieve meaningful ranges that are, for example, relevant for real-life commercial aviation, we knew we had to take a next step. And the next step means switching from using gaseous hydrogen as a fuel to liquid hydrogen.
Right. Okay. That's excellent and very well explained. Thank you. And what are the challenges for using liquid hydrogen?
Yeah, sure. Let me explain that. I think, sure. So maybe the best place to start is to explain the difference between gaseous and liquid hydrogen, because that really explains why fueling is so unique and why we want to do the switch from gaseous to liquid.
Please do. Please do. Yeah.
So when hydrogen is stored as a gas, it has a very low energy density by volume, which means you need very large high pressure tanks to store it. But the problem is those tanks take up a lot of space. And in an aircraft context, that would mean we would sacrifice payload, for example, passenger seats. So when you cool hydrogen down to minus 250 and 3 degrees Celsius, it becomes liquid. And liquid hydrogen is much denser than gaseous hydrogen, so you can store far more energy in the same space.
But it's got to be kept very, very, very cold.
Exactly, the minus 250 degrees Celsius, that's super cool.
Yeah.
But for aviation, that's a big breakthrough, because this is what allows you to think about longer flights and eventually using larger aircraft. So that is like the basic knowledge you need to know.
No, that really helps. That sets the context. That's really, really cool. So there, clearly, the obvious question is the challenge with regards to the cooling. What was done in order to maintain the hydrogen at the temperature needed to keep it liquid?
Yeah, so there are several challenges we need to solve, whether it's the tank, but also the fueling process itself. So what you need to know is as soon as you start transferring liquid hydrogen, a small amount naturally warms and boils off into gas. And that gas builds pressure in the tank, and we don't want to have that pressure in the tank. So we use a so-called vent mast. And this vent mast releases this gas safely, and the gas is like high above the aircraft where it can disperse.
Right.
That's one thing.
And the cold thing?
Yeah, and also the cold thing. We need to keep the hydrogen cold while transferring it from the storage trailer all the way into the aircraft tank. And therefore, it sounds quite simple, but we just use very, very well insulated piping. That's the thing when transferring it from the storage to the tank. Mm-hmm. And now in terms of the tank, so the tank on the aircraft itself, to keep it liquid and to avoid adding any unnecessary weight, we use a design that's a bit like a thermos bottle.
Okay.
Like, you know, it with your hot tea.
Yeah.
So you have an inner tank, you have an outer tank, and between the inner and the outer tank, there's a vacuum and also a multi-layer insulation in between. And this tank concept enables us to keep the fuel cold without adding any active cooling on top.
Okay, you must have taken a lot of iterations to develop the tank and the methodology that actually worked. You must have been thrilled when you saw that it was actually possible.
Yes, definitely. And also when it comes to iterations in safety, you do a lot of testing before integrating such a tank system into an aircraft. So there's a lot of testing in the lab. You prove, are there any leaks? Is it really cooling the way it should cool? So a lot of testing that comes beforehand, before even integrating and flying such a system in an aircraft.
So after all that testing, did the project actually manage to fly an aircraft using liquid hydrogen?
Yes, absolutely. And I think that is really what excites me the most about this project, that it really led to this genuine world's first I mentioned earlier. So we were really able to complete multiple flights, world's first flights, with this electric aircraft powered by liquid hydrogen. And I think what I can tell you from my personal experience, I was on site, and I'm also, like Magali, not a technical person, but like when you see the aircraft taking off, when you see it flies smoothly and it lands safely, it was an incredibly meaningful moment for the entire team. And I think seeing the aircraft in the air was the most tangible proof you could ask for that concept we've been developing. And yeah, showing that it really works in those real flight conditions.
Fantastic. Thank you so much. You've explained that very, very well. You know, you and Magali are both doing something very similar beyond the notion of hydrogen and transport. Both of you are bringing in a disruptive technology to a context which is very firmly established in previous ways of doing things, right? Existing technology. So if you think about it, Melanie, overall, what do you think is the one part of the disruptive technology that is going to perhaps be the biggest challenge for commercial aviation to implement? Where do you think they're going to be really scratching their heads?
Mm-hmm. I think it's not about the technology. I think a lot of people think about the technology as this big engineering challenge, and probably the most or the biggest challenge when it comes to having like commercial applications. I think the bigger challenge will be to have sufficient green hydrogen as a fuel.
Well, I'm very glad you said that. That's fantastic, because I'll let you complete your sentence in a second. But that, Benedict, you're nodding, right? So, because I'm going to turn to you in a second about storage. So, yeah, sorry, continue, Melanie. Sufficient green hydrogen.
Yeah, so we need sufficient green hydrogen. So what we really need to continue to do is build out our renewable energy capacity to have enough green hydrogen, which is needed. Like, if we can have the best technology, we can prove 100 of times that it works, but we need the hydrogen fuel, and we also need the infrastructure at the airport.
And when we say clean hydrogen, of course, we're talking about hydrogen that's derived from clean electricity, I think is what you mean. Yeah.
Exactly.
Yeah, because we've been saying clean and green hydrogen. We need to clarify that means that it's drawing on electricity, which is clean and green. Fantastic. Thank you so much, Melanie. Benedict, yeah, good time for you now.
Yeah.
Talking about the infrastructure there, weren't we? So that leads on very neatly to you. The EU H2 STARS project is demonstrating the efficacy of underground hydrogen storage in depleted porous natural gas reservoirs. So Benedict, why, and I think we've got a good lead into that, was the work done by the project so important?
Well, the nice thing about hydrogen is that hydrogen is an energy carrier which you can store in large volumes over long durations of time, which we will need in our future renewable energy system. Actually, in summer months, already renewable energy has to be curtailed, so shut off, instead of being stored for times where there's a huge need for energy. And this is where hydrogen can be a very important solution, and the storage of hydrogen especially. What I'm really happy about is that we, in our project EU H2 STARS, we don't only show how important hydrogen storage is for the overall system, but we actually are operating our demonstrator plant in Upper Austria, which is the world's first underground hydrogen storage in a depleted gas reservoir, which makes it quite unique and special. And yeah, it's very nice for me that we don't only show PowerPoint presentations on how great this would work, but we're actually doing it.
Yeah, you actually have a proof of concept. There it is. Yeah. I like all these world firsts. Very good. Super. So what are the challenges of storing hydrogen in pre-existing gas storage?
Well, maybe first I can describe what this storage looks like.
Yeah, please do.
So it's not a tank. It's not a tank buried in the ground or a big cave or something like that. It's sandstone in 1,000 meters depth, where a well is drilled into. So in the first place, there was natural gas inside. So we already know that this storage reservoir is gas tight, so that gas doesn't go away. And now that the natural gas is withdrawn, and now we can use this geological formation to store hydrogen. That's been done for natural gas for quite some years now, that you store natural gas in summer months and withdraw it again in the winter. And we now show that it's also possible and feasible for hydrogen.
Okay, that's fantastic. And so tell me how this works. I mean, you pump the hydrogen in and then you pump it out again? Tell me a little bit about the to and fro and the infrastructure for that.
Yes, well, at the first place, we need the hydrogen to come from somewhere, maybe imports, maybe electrolysis directly at the plant. And then we compress the hydrogen. So yes, we pump it down. And to withdraw it, we just open the valve again quite slowly and withdraw the hydrogen. And this way we can shift the energy from times when there's lots of energy to times where we need the energy.
Right. So I mean, perhaps we could even think of it as being the equivalent of water, really. You fill up the well and then you draw it off. Excellent. But there must have been some technical challenges involved. Can you tell us a little bit about some of the problems the project's had to overcome or is overcoming, because you're still ongoing as a project?
Yes. Well, we are very confident on the technical side. So we've had much know-how on this topic and could deploy it here. What we are actually doing now is developing safety standards so that everyone knows how to do. We are also developing plans for bigger facilities, as this is a demonstrator with a capacity of 1 million cubic meters of hydrogen, which is quite large, yes, but we need larger facilities in the end. And we are developing blueprints for storage sites all across Europe, which is the nice thing, I think, about this project is that it's not just for us, it's for the overall society.
You're spreading the joy.
Yes.
Yeah. Excellent. And are other areas showing interest? I mean, do you have sites identified for other regions and places?
Yes. So within our project, we're 11 partners from 5 countries in Europe. And in 4 of these countries, we already have sites where a new underground hydrogen storage plant could be built. Okay,
you've identified locations which could work.
Yes, that's and we also are doing the planning for the construction within this project.
Oh, that's fantastic. Super. Thank you very much. And again, like the other 2 wonderful guests we've had this morning, it's very practical. So that's excellent. It's not theoretical. You're actually up there making this more feasible as a part of the renewables mix. Excellent stuff. I was wondering, again, I suppose it's a bit like the question I asked earlier. I'm very curious to get a kind of an idea of what the future looks like. What do you think? In 5 years, 10 years time, do you think that we will be using hydrogen as part of the overall energy mix? What do you feel? More, I mean, obviously more.
Yes, I think that's quite clear. Hydrogen is being used right now, and the gray hydrogen, so the not so green we are using right now, will be substituted by green hydrogen, and even more hydrogen will be used in sectors where electrification is not that easy to do. And hydrogen storage as part of the overall hydrogen infrastructure will be an important puzzle piece in the future energy system.
Absolutely. Yeah. No, otherwise we don't have our wonderful new aeroplanes taking off and our wonderful new buses pottering around inner cities. Okay. Thank you so very much for your time. You've all explained the work that you've been doing very, very well. And it does make it feel much more tangible as a larger composite into the energy mix. Thank you very much.
Thank you.
Thank you very much.
Thank you.
You're welcome. It was a pleasure having you with me today. Goodbye.
Bye.
Bye.
If you've enjoyed this podcast, follow us on Spotify and Apple and check out the homepage on the Cordis website. Subscribe to make sure that the hottest research in EU-funded science isn't passing you by. And if you're enjoying listening, why not spread the word? We've talked about the parasites that krill host and what they can tell us about the biodiversity of our oceans and how to print a house. In our last 52 episodes, there'll be something there to tweak your curiosity. Perhaps you want to know what other EU-funded projects are doing to boost the uptake of hydrogen. The Cordis website will give you an insight into the results of projects funded by Horizon 2020 and Horizon Europe that are working in this area. So, come and check out the research that's revealing what makes our world tick. We're always happy to hear from you. Drop us a line, editorial@cordis.europa.eu. Until next time.